Morning students, today we will start exercise 1.3, but for your recall I want to say that already in the beginning of this chapter I had explained the classification of real numbers. There we had got that there are two types of real numbers, rational and irrational numbers, and I had explained their properties there also, but for your recall I am just explaining once again it. Look here. Rational numbers are of the form P by Q, where Q is not equal to 0 and P and Q are integers. This is the condition for a rational number. I am giving examples. You can take 0, 1 by 2, 1 by 3, 1 by 8, 22 by 7. These all are rational numbers. But when we see all these numbers carefully, we used to get that 1 by 2 is 0.5. 1 by 8 is 0.125. 1 by 3 is equal to 0.333. Infinitely it will go on. 0.3 bar we can write. Like this 22 by 7 is also, this is 3.142857, and like this it will go on. So we can write this is 3.142857. Here group of digits repeated. 1 by 6 you can take example. This is 0.1666 ... Thus we are getting it is 0.16 recurring on 6. So we are getting two types of numbers. Either they are terminating or they are repeating. Here single digit is repeated. Here a group of digits is repeated. So we can say that rational numbers are those numbers whose decimal expressions are either terminating decimal or repeating decimal. Like this, we will take the case of irrational numbers. Irrational numbers are those numbers whom we can't express in the form of P by Q, where Q not equal to 0 and P and Q are integers. It cannot be expressed in this form. Then we say that those numbers are irrationals. Examples you can take: root 2, root 5, 2 plus root 3, pi. These all are irrationals. So why these all are irrationals? Here root 2 is actually, this number can be written as here 1.414 ... Root 3 is 1.732 ... Pi is 3.141592 ... So here we are getting that neither they are terminating nor repeating. So we conclude that irrational numbers are those numbers whose decimal forms be neither terminating nor repeating decimal. But remember one thing, all transcendental numbers are also irrational numbers, but all irrational numbers are not the transcendental number. Now let us start the exercise. Let us start exercise 1.3. It's very important exercise. Since from this exercise one question of 4 marks will be asked in board exams, and here in this exercise there are only 3 questions. So relax first of all, and then you see how we can do these questions. Question number 1 is saying prove that root 5 is an irrational number. So we will give the contradictory answer. So I am starting the answer. Look carefully. Let, if possible, let root 5 is a rational number. As we know that rational numbers can be expressed in the form of P by Q, so we can write under root 5 equals P by Q, where Q not equal to 0, P and Q are co-prime integers. Squaring both the sides, root 5 whole square equals p upon q whole square. Squaring both the sides. Both sides. Root 5 whole square will be 5 and RHS will be p square upon q square. This implies p square equals 5q square. Then we are getting thus p square is a multiple of 5. This implies p is also a multiple of 5. Multiple of 5. This implies p can be written as 5m, where m is some integer I. Squaring, we are getting p square equals 25m square. Now we have two values of p square. One value is p square equals 5q square. Another value is p square equals 25p square, 25m square. Now we will equate these values. Now 5q square equals 25m square. This implies q square equals 5m square. Thus q square is the multiple of 5. This implies q is also a multiple of 5. Also a multiple of 5. Hence p and q both are the multiple of 5. Multiple of 5. It is a contradiction. It is a contradiction with the fact. What is the condition? That there will be only common factor between p and q will be 1, since they are co-prime integers. And here we are getting 5 is common between p and q. Thus we are getting a contradiction. Hence our supposition is wrong. Hence our supposition is wrong. Supposition is wrong. Therefore, root 5 is an irrational number. An irrational number. Let us move. I think it's very, very simple one. When you will do practice, then you know where you will be getting any problem. Come to question number 2. It is asking that prove that 3 plus 2 root 5 is an irrational number. Let us see. It's also so simple. If possible, let 3 plus 2 root 5 is a rational number. This implies 3 plus 2 root 5 can be expressed in the form of p by q, where q not equal to 0, p and q are integers. This implies 2 root 5 equals p upon q. Now I am carrying this 3 from LHS to RHS. In this side it is plus, so this side it will be minus. We will take the LCM q. Now it is p minus 3q. I have simplified. This implies root 5 equals p minus 3q by 2q. Since here 2 is in the form of multiple, that's why in this side it will be in division. So this here p, q, 2 and 3 are integers in RHS. Therefore, p minus 3q by 2q is a rational number. But root 5 is an irrational number. Thus we get a contradiction. It is a contradiction with the fact. Hence our supposition is wrong. Hence our supposition is wrong. Supposition is wrong. Therefore, 3 plus 2 root 5 is an irrational number. Irrational number.